discuss the second conic section, which is the parabola. Now, let us define parabola. Parabola is the set of all points in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus. We have here 4 illustrations showing the different positions of a parabola. In the first illustration, we have a parabola opening upward. On the second one, a parabola opening downward. On the third one, we have a parabola opening to the right. And lastly, we have a parabola opening to the left. Now, we have different parts of a parabola. Let's get to know that. Number 1, we have the focus. A focus is a fixed point in the interior of a parabola. Now, looking at the illustration number 1, the only point inside or in the interior of our parabola is this one, because this is our parabola. So the only point inside it is this point. Therefore, it is our focus. So we can write under it. Okay, so this is our focus. Number 2, we have axis of symmetry. Axis of symmetry is a line that bisects the parabola. When we say bisects, it divides the parabola into 2 equal parts. Now, looking at the illustration, the only line that bisects the parabola into 2 equal parts is this line. Therefore, this is our axis of symmetry. Third one, directrix. A directrix is a line perpendicular to the axis of symmetry and does not touch the parabola. When we say perpendicular, it forms 90 degrees. 2 lines that form 90 degrees. So in our illustration, a line perpendicular to this one that does not touch the parabola is this line. Therefore, this is our directrix. Okay, fourth one, we have the vertex. A vertex is a midpoint between the focus and the directrix. So when this is our focus and this is our directrix, the midpoint of these two is this point. Therefore, this is our vertex. We can write it as letter V. Okay. And lastly, we have our focal diameter. It is a length of line segment that runs through the focus and the endpoints on the parabola. Okay, a line segment that runs through the focus and the 2 endpoints of the parabola is this one. So this is our focal diameter, and it measures 4p. Okay, so we can write from this point to this point, it measures 4p. And since it is bisected by an axis of symmetry, we can say that from this point to this point, it measures 2p, and from focus to another endpoint, we have 2p. So overall, we have 4p. Okay, so our focal diameter is 4p. You will understand it later why 4p. Now we already know the different parts of a parabola. Let us determine the different parts of our parabola in the second, third, and fourth illustration. We have the parabola opening downward. So our focus is here. It is a point inside the parabola. And we have our directrix here. The line at the back of the parabola. Okay, always remember, directrix is always on the back of the parabola and focus is always on the front or on the interior of the parabola. So a midpoint between directrix and the focus is our vertex. So this is our vertex, this point. So these 2 points are the endpoints of the parabola, and this line that bisects the parabola into 2 parts is the axis of symmetry. So this is our axis of symmetry. And our focal diameter here, it measures 4p. Okay, that is constant, 4p. So from this point to the focus, 2p. Then from the focus to another endpoint is also 2p. So overall, we have 4p. On the third one, we have our focus here, our vertex, our directrix, our axis of symmetry, this one, and our focal diameter is. On the fourth one, we have our focus here, our the different parts of a parabola. Since we have 4 positions of a parabola, the upward, downward, to the right, and to the left, we can say that each of the positions of a parabola has its own pattern of equation. What is the pattern if the parabola is upward, if the parabola is downward, if it is facing to the right, or if it is facing to the left? Now for you to know it, I will introduce you the standard equations of a parabola. So we have here parabola with vertical axis and parabola with horizontal axis. Now what does it mean by parabola with vertical axis? When we say parabola with vertical axis, these are parabolas that goes with the direction of the vertical axis, which is the y-axis. So y-axis. Now in our Cartesian plane, our y-axis is here. So this is our y-axis. So all parabolas that go with this direction, vertical, have equations of x minus h squared is equal to 4p multiplied with quantity of y minus k, wherein p is not equal to 0. So parabola with vertical axis, we have parabola opening upward and parabola opening downward, because these two parabolas go with the direction of the y-axis. Okay, so they should follow this pattern of equation. On the other hand, parabola with horizontal axis are parabolas that go with the direction of the x-axis. Our Cartesian plane, our x-axis is here. So all parabolas that go with the direction of this line have equations of y minus k squared is equal to 4p times the quantity of x minus h, wherein p is not equal to 0. So in our illustration, we have two parabolas that go with the direction of the x-axis. We have the parabola opening to the right and the parabola opening to the left. So these two parabolas should follow the pattern of this equation. Now let us study the standard equation number 1. X minus h squared is equal to 4p multiplied by the quantity of y minus k. In this equation, the variable being squared is x. So we can say that our parabola will either open upward or downward. Now in this equation, how do we really determine if our parabola opens upward or downward? That's very easy. We just look at the value of p, or 4p. If our p is greater than 0, our p is greater than 0, or shall we say our p is positive, therefore our parabola opens upward. On the other hand, if our p is less than 0, that is negative, our parabola opens downward. So we can write it as x minus h squared is equal to negative 4p y minus k. p is 0. So if p is less than 0, our parabola opens downward. On the other hand, with the parabola with horizontal axis, that is the variable being squared here is y. Now how do we determine if the parabola will really open to the right or to the left? Again, just look at the value of 4p or p. If p is greater than 0 or positive, our parabola opens to the right. And if p is less than 0 or negative, our parabola opens to the left. So we will write y minus h squared is equal to negative 4p x minus h, where p is not equal to 0. So when p is less than 0, our parabola opens to the left. Okay. Now we already have the equation of each of our parabolas here. For the first one, x minus h squared is equal to 4p quantity of y minus k. Since the variable being squared is x and our p is positive, therefore our parabola opens upward. Next one, x minus h squared is equal to negative 4p y minus k. Since the variable being squared is x and our 4p is negative, or our p is negative, our parabola opens downward. On the other hand, our variable being squared here is y and our p is positive, our parabola opens to the right. And lastly, y minus k squared is equal to negative 4p x minus h. The variable squared here is y and our p is negative, therefore our parabola opens to the left. So the last illustration. So this is how to determine the position of the parabola. We have here 4 examples of equations of a parabola. So let's determine the position of each parabola if they're being graphed in a Cartesian plane. Example number 1, we have x minus 1 squared is equal to 8 times the quantity of y plus 3. So the variable being squared here is x. So we can say that it goes with the direction of the y-axis or the vertical axis. And since our p is positive or greater than 0, we can say that our parabola opens upward because it's positive. Next example, quantity of y plus 4 squared is equal to negative 4 times the quantity of x minus 6. So the variable squared here is the variable y. Therefore, it goes with the direction of the x-axis or the horizontal axis. And since our p is negative or is less than 0, we can say that our parabola opens to the left. Third example, we have quantity of x plus 3 squared is equal to negative 12 times the quantity of y minus 5. So since the variable being squared here is x, we can say that it goes with the direction of the vertical axis or the y-axis in a Cartesian plane. So the y-axis. And because our p is less than 0, it's negative, therefore, our parabola opens downward. Okay, last example, we have y minus 4 squared is equal to 6 times the quantity of x plus 2. So the variable being squared is y. Therefore, we can say that it goes with the direction of x-axis, which is opposite to the variable y, so the x-axis. And since our p is positive, that is greater than 0, because positive, we can say that our parabola opens to the right. Okay, so since we already know how to determine the position of a parabola given the standard equation, now let's do the graphing. So let's try to graph example number 1. X minus 1 squared is equal to 8, quantity of y plus 3. So we already know that this equation of a parabola opens upward because the variable being squared is x and our p is greater than 0 or positive. So this opens upward. But next to that, we will first determine its focal diameter, its vertex, and its focus. So in our standard equation, x minus h squared is equal to 4p y minus k. Our focal diameter here is 4p. Now, in our equation, in place of 4p, we have 8. Therefore, our focal diameter here is 8. So, our focal diameter is 8. Now, next to that, we will need to get the p, because we need p in order to find the coordinates of our focus and our directions. So, 4p is equal to 8. So, dividing both sides by 4. So, cancel, p is equal to 2. So next, we will get the coordinates of our vertex. Now in the circle, the point HK is the center of the circle. However, in parabola, the point HK is the vertex of the parabola. So in our equation, our H is here and our K is here. Because it's negative 1, our H will become positive 1. Because our K is positive 3 here, the additive inverse of positive 3 is negative 3. That's why our k is negative 3. So our vertex HK is 1 and negative 3. Now let us determine the coordinates of our focus. So we have here our formula. Our x coordinate is h and our y coordinate is k plus p. So we can write, since our h is 1, so our x coordinate is 1 and our y coordinate is k plus p. Since our k is negative 3, we can write negative 3 plus p, which is 2, our p is 2, so plus 2. We'll solve for this one. Therefore, our focus is 1, negative 3 plus 2 is negative 1. So our focus is 1 and negative 1. Now, if you don't want to memorize this formula, all you just have to do is to look at the variable that is being squared in the equation. Okay, variable being squared is x, okay? The variable being squared here is x, therefore, the x coordinates of our vertex and our focus is just the same. That is, if you don't want to memorize this formula anymore, but you can have this option also. Since we already have our focal diameter, our vertex, and our focus, we can now sketch our parabola. So first to plot is our vertex. Our vertex is 1 and negative 3. So our x is 1, our y is negative 3. So negative 3, 1, 2, 3. So our vertex is in the 4th quadrant. Next is our focus. We have 1, negative 1. So as I have said earlier, our x coordinate is just the same because our parabola goes with the y-axis. So it just align here. So our focus is 1, negative 1. So 1, negative 1. So our focus is here. Now, we have to determine the two endpoints on the parabola so that we can sketch our parabola. Now, how to determine the two endpoints on the parabola? We will use the focal diameter, which is 8 units. So from the focus, we have to count 4 units to the right and 4 units to the left. So all in all, if we add 4 plus 4, our focal diameter is 8. So from our focus, 4 units to the right, 1, 2, 3, 4. Again to the left, 1, 2, 3, 4. Okay, so we have the focus and the two endpoints on the parabola. So we can now sketch our parabola. So we sketched our parabola connecting our vertex and the two endpoints on the parabola. Now next is we will determine the directrix of our parabola. Now remember, the directrix of a parabola is always on the back of a parabola. Therefore, we can find our directrix somewhere here at the bottom of the vertex. Now, since the distance from the vertex to the focus is 2 units, therefore, the distance from the vertex to our directrix is also 2 units. Okay, so we will count 1, 2. Therefore, our directrix is somewhere here. Okay. Now, we have to know the equation of our directrix. In order for us to know the equation of our directrix, we just have to know the axis that it touches. So it passes through the y-axis. Therefore, we will write y is equal to one certain coordinate on the y-axis. So we will count from the origin. We have negative 1, negative 2, negative 3, negative 4, negative 5. So y is equal to negative 5. So our equation is y is equal to negative 5. As I've said a while ago, we can use P in finding the coordinates of our focus and our directrix. So we have 2 units here from vertex to focus, the same with the vertex to directrix. We have 2 units because our P is 2 units. So we use this one in finding the distance from this one, which is 2 units. And again, from vertex to directrix, we have 2 units. The measurement here is equal, always equal. The same with the focus to the right endpoint of the parabola, we have 4 units. And from the focus to the left endpoint, we also have 4 units. So that if we add 4 plus 4, all in all, we have 8 units, which is the focal diameter of our parabola. So focal diameter is 8 units. Okay. Then lastly, we have to label our parabola. So how to label? We will use the equation given. So we just have to write x minus 1 squared is equal to 8y plus